Okay, hello everyone, I'm Jose Valim. My talk today is about a new programming language on top of the Erlang virtual machine called Elixir. I'm not going to spend those 30 minutes talking how you're going to do X or Y with Elixir. I actually want to tell you why I'm creating a new language and why I think it's important, because I think this way, showing the rationale behind my decisions, and I think it will be easier for me to make an impression on you and have you getting started and playing with it. Right. So this talk, I'm going to answer some questions, and the first one I will start answering is why. So why I'm creating Elixir, and to do that, I'll do a little bit of background. So I'm a Brazilian guy. I live in Poland, and I have a consultancy company in Brazil called Plataforma. And I come from a web development background, right? We today have 20, we are 20 people, and we work with big companies in Brazil. And the reason why we are attractive to those companies in Brazil and startups around the world is because one of our goals is to deliver projects with very good technical quality, right? So we aim for technical quality. And this is a little bit hard to do with the web because the web is always changing. I have almost 10 years working with the web, and if I look how I was developing web applications 10 years ago, and how I develop today, the techniques, the technologies we use, they changed a lot, right? And we have a bunch of revolutions going on right now, like NoSQL, people like Google are trying new protocols, and what I think is that one of the directions the web is changing now, because I think that in the next 10 years, the way we build stuff for web will be again different from what we do today. So I think that the way the direction the web is moving now, it's good for the Erlang community, and it will be good for the Elixir community as well, right? And I'm going to show you some cases which proves this point, right? So the first one, so let me do some questions first. Who already work with web development somehow? Okay, good. And who heard of Speedy already? Okay, Speedy is a protocol by Google. It has some ideas, and if you use Chrome, the browser Chrome, and you use Gmail, we are using Speedy, right? And it tries to solve several problems. I'm going to talk about one. So one of the things is that if you go to Amazon today, you're going to see, and you use Chrome or Firefox, and you see the number of requests, you're going to see that your browser is doing 64 requests to the server. And that's because Amazon already optimized the shit out of it, right? Amazon reduces the number of requests you have to do to the server the maximum they can. And you still need to do 64, right? And this is a little bit broken because it works basically this way. When your browser goes to the Amazon web page, it usually opens like 4 connections to the Amazon Web Service, right? And then what is happening is that your browser say, hey Amazon, send me this page. And then it sends the request to Amazon, and then Amazon responds back. And just after Amazon responds back, your browser can say, now send me this image. Now send me this other image, right? So you can see that those things, they are in series, right? They're not happening in parallel. The connections are parallel, but in one connection you cannot have parallelism, right? This is what we call a keep alive connection, right? So what is happening, the browser goes, access to Amazon's web servers, and leave the connection open. And one of the things that Speedy makes easy is the approach called pipeline, which is basically the client saying, hey, I want this page and I want this image, and it sends everything straight away, right? And then the server is going to reply what he has, and it can even give more responses than the number of requests, because the server can say, I know that you're going to need this image, right? So I'm already sending it to you. And then this can give a good experience when the user is using the website, because the page is going to load much faster, right? So what is happening here is basically that the web grew a lot around the CGI approach, which was basically you had a browser, like this is a very old approach, right? So I'm even using the Netscape browser, which many people probably not even heard about it. And basically, what this approach is basically, you have the browser doing a request, and then you have the CGI, which is a common native interface that's parsing all the information and invoking a process that's going to get information back. So we have those explicit steps, right? I have a request, someone processes the request and sends it back. And this approach no longer works, right? Because what we want is that we want to have kind of control of the connection to push stuff down the connection whenever we want, right? So we want to have control of the connection. We want to have better abstractions and not use the abstractions that people are using like 10 years ago, which is basically around operating system processes. Right, so this is one of the things, right? We need better connection handling. And the second thing that proves that Erlang and Elixir, they are good alternatives for the future are smarter clients, right? So what is happening is that it doesn't matter in the future if you're going to use HTML5 to build your applications, or you're going to use iPhone or Android devices. One thing that's happened for sure is that logic is moving from the server to the client, right? The clients, they are getting smarter, right? And this is good because it's a paradigm shift. Okay, so every time you have a paradigm shift, it's a good opportunity to introduce new technologies, right? And it also requires long-running connection, right? You have your iPhone, like you have Twitter on your iPhone. You need to synchronize the tweets, right? You need to connect to the server and say, hey server, give me all the tweets that happened in the last 8 hours. It can be a lot of stuff, right? So you need to open the connection and exchange the data, right? And we're also seeing an increase on serialization protocols as well, because if instead of sending 1 megabyte, you're sending 800, we have a 20% gain, that's good. And the third case is multi-core, right? Erlang developers, they have this discussion happening for a long time already that we are going to, in the future, using more and more cores. It may happen, it may not. But the fact is that my machine has 4 cores, right? It's very easy today to get a server that has 16 cores. So it would be nice to have a technology that can use all of these cores by default. So, given those 3 cases, I ask you the question, which technology is well known for handling many long-running concurrent connections, right? It's Erlang, right? You have very good reports of people like, hey, I'm using WebSockets on this Erlang machine, and I can get 500,000 connections open, right? There is an application for a mobile device called WhatsApp, and those guys are able to have 2 million TCP connections in just one node. They have the whole infrastructure in just one machine running Erlang, so that's awesome. So these are my motivations, right? I want to provide better tools for the web. So now that you know that, the next question is what? So what are you trying to achieve? Now that we have this goal, what are you trying to achieve? So another background then, is that I'm part of the Rails core, who already used or heard about Rails, Ruby Rails. Okay, a lot of people, that's nice. And Rails is like one of the biggest web frameworks out there, not in terms of size, but in terms of people using it, right? And Rails' main focus is not on speed, it's on productivity. It's on developer productivity, okay? So the idea is how I can make the environment more productive, right? This is one of the goals in Elixir. I want to be more productive, right? And the second goal is also related to Rails, because Rails is built on top of a language called Ruby, and Ruby is extremely dynamic, and Ruby is extremely extensible, right? So the second goal is extensibility, right? But this is kind of a hard line to walk, because we need to be careful, because if you try to make stuff too extensible, it cannot suit well with Erlang, because Erlang requires an explicit compilation step, and you need to play well with the code server, so you need to control the line here, right? So this is the second goal, extensibility. And the third one is that I still want Elixir to be able to do the same things a developer could do with Erlang, which is basically be able to build, distribute fault-tolerant applications with hot code swapping, right? So hot code swapping should work. I should be able to build distributed systems easily, right? So the third goal is compatibility. Elixir should play nice with Erlang, okay? So this is the second question, right? What I'm trying to achieve: productivity, extensibility, and compatibility. So how I'm going to achieve those goals? So now I'm going to give you a quick run of Elixir features, okay, and show how they are related to those goals. So the first one is homoiconicity. Who already used Lisp? Yes, not many. So the whole idea of homoiconicity is that you can use the language constructs to express the language itself. Erlang is homoiconic, right? And it has a language type format that you can build and pass Erlang to build the right code for it. Okay? And Elixir is also homoiconic, and we provide several features around this homoiconicity. So for example, here is Elixir code, right? So I'm checking if something is an atom, and atoms in Elixir, they are represented by the column, right? They start with this column, right? And this is represented internally as a tuple with 3 elements. The first one is the function name. The second one is the line where the function is happening, is written. And the third one are the arguments that I'm passing to this function. And almost everything in Elixir is built around this simple expression, right? Even operators. So if you do 1 plus 2, this is actually a call to a function named plus at line 1 and with the arguments, receiving the arguments 1 and 2, right? And then we can do that in Erlang, right? We have similar features, right? But what Elixir adds that Erlang doesn't are macros. So who programming with Lisp, you have this idea of macros, which is basically code that is able to generate code, right? And that's the idea of the productivity, right? I'm able to generate code that can do the work for me, and this is great. So a very common example of macros is to define an unless thing, which is the opposite of do, right? So I can, if true, do this, or now using the macro unless that I defined, I can do unless true, do this, right? This is a very simple example. And the good thing with macros is that we can define domain-specific languages. And this is important because frameworks, libraries, they can provide macros, they can provide abstractions that do the hard work for us, right? When we look at the surface, it seems simple, but what is happening underneath is a lot of work, right? And that's the whole idea of domain-specific language, is encapsulating what is happening behind. So one example you could do with this idea of domain-specific language, and in the context of the web server, is the following, right? Imagine that you have a web server, and there is a request. You need to respond to this request, right? But the way you want to respond to this request changes if the request, for example, if the client is asking for an HTML page, or if the client is asking for a JSON representation of an object, of a record, right? So how you could do? So for example, you could do this, right? So I respond to the request, and if the format is HTML, which is red, I'm going to render a template. But if the format is JSON, I'm going to convert this record to JSON, right? And you say, this is actually simple, right? But there are a lot of stuff happening behind the scenes, because what this needs to do is that it needs to go to the request and see what the request accepts as a response, right? So every time you do a request to a web server, your browser sends something like this, right? Oh, I accept HTML, I accept JSON, but if you don't have any of those two, right, you can send me whatever, which is a star, /star. You can send me a whatever and then try to render it, right? And then that we know what the client wants, we need to know what the server has available to give back, right? So in this case, we defined HTML and JSON. And then we are going to negotiate the format. We need to check what the request wants, what the response has, and decide which piece of the code you're going to invoke, right? Which would be to render a template. So this is the whole idea, and the whole idea of having macros, constructs that can do the hard work for me and still look very simple from outside. Okay. The second feature in Elixir is executable definition, and this is funny because like a week ago, Joe Armstrong, he said something to the Erlang questions waiting list about ER2, which the main feature of ER2 is to actually have executable definition, right? And Elixir has it. Basically, in Erlang, you can write this. You're defining a simple module, right? And what you can put in the module body is very limited set of instructions. You can put attributes, you can put functions, but you cannot put random code like this, right? I cannot do this. So in Elixir, you can do that, right? But you can say, why do you want to do that, right? Why do you want to print something when you're compiling a module, right? The whole idea is that you can mix this with macros, right? So who uses Rails can recognize something like this, right? Now I have this has many things, this has many macro that can generate functions in my module, and then it can generate, it abstracts all these boilerplate code, right? And it's doing all the work for me again. It's generating, it's handling the abstractions for me. So those are the two features that I think that they are related to productivity, right? It's basically homoiconicity and macros. And you can do this kind of stuff in Erlang and use parse transforms. But the point here is that since it is supported by the language, for you to achieve the same behavior, you actually need to write much less code, right? And we know if less code, less bugs, right? As they say, there is no code better than no code. Okay, third feature is related to extensibility. And this feature is called protocols. Now, another tricky question, who used Clojure or worked with Clojure a little bit? Okay, even less than this. Next time, if you are interested to, Clojure is a Lisp, so if you're interested in learning a Lisp, try Clojure, it's very interesting. And Clojure has this idea of protocols, and it's basically the following. Imagine that I have an application and I need to convert a structure, or I need to convert something to JSON, right? In Erlang, I could write a JSON library like this. Okay, so basically I define a module JSON, and I'm going to define the implementation, right? So to JSON, and when the item I want to convert is a list, I'm going to do something. If the item I want to convert is a binary, I'm going to do something else. If the item I want to convert is a number, I'm going to do yet something else, right? And this is bad because imagine that I'm using this library and at some point I realize that using arrays instead of lists would be better for my application, right? Now I'm busted because the implementations, they are written in the source code, right? The only way for me to add how to serialize arrays is if I actually copy this code, put it somewhere and change it, right? The whole idea of protocols is to have ad hoc implementations, right? So with Elixir, and you do something similar with Clojure, it's basically to define a protocol. So I say, I want to define a protocol JSON, and to implement this protocol, you need to implement the toJSON function, right? And then you define the implementation of the protocol ad hoc. It's not inside in the same place where you define the protocol. So here I will define the implementation for lists, for binaries, for number, and then if in the future I want to use arrays, I just go there and define the implementation for arrays, right? There is no need to mingle with the source code. So this is one of the features that help me achieve extensibility, right? So I'm not locked on the design that the person that wrote the library in the first place had in mind, of the data structures that the person had in mind. Okay. The fourth feature is easy to explain, is compatibility, right? And basically there is no conversion cost for calling Erlang for Elixir, vice versa, right? So calling an Elixir function for Elixir is the same cost than calling an Erlang function from Erlang. And you can call each other and there is no extra cost, right? And that's because they are built on the same abstractions, right? So in Erlang, what you have is that you have those namespaces, those modules represented with atoms, right? And then when you want to call something, an atom in a function, you're basically using, you can think that you're using the column operator, right? And passing lists and flatten. And Elixir is the same idea, right? So if I want to call something in a module, I'm just going to call something in the atom that represents this module. And the bytecode they're going to generate at the end is exactly the same, right? But if you feel weird calling something in the atom, you can use a very simple wrapper. So you can call erlang.lists and then you're calling an Erlang function. And finally, the more natural way, idiomatic way to do this in Elixir would actually to set up a reference. So I can say that now every time I call something list, I actually want to call something Erlang.lists, right? And the nice thing is that those features, they happen at compilation time. At the end, you can write Elixir code that when compiled has no dependency at all in Elixir, right? At the end, it's just bytecode, and you're going to use it whenever you want. So we have other features like references, I briefly mentioned, dynamic records, but I don't have the time to go into it. We have a getting started. I'm going to show you links soon. So the fourth question, the last question, is when, right? So when things are happening. So today is kind of the release of the website. I put a lot of work wrapping up the documentation and putting up a website where people can go and check and have a getting started guide and learn more about the language. In March, I want to release the 0.9 version of Elixir, and the reason I'm jumping to 0.9 is because I want to show that this is a commitment, right? I think that the point we are now is a very solid point, and we are ready to be 1.0 in 6 months, right? Or something like that. And then the other date is in May. I want to do the beta release of Dynamo, and you can ask like, what is Dynamo, right? And Dynamo is a fast async web framework built around the socket, which is basically, I'm trying to build a low-level web framework around Erlang web servers like Cowboy, the retired Byzantine, and things like that. And it's easy for us to solve the problems I described at the beginning of this talk. So if you go to the website is this. I'm going to give you the link. There is a getting started guide at the top, and that's it. So you can follow us on Twitter at ElixirLang, and the website is elixirlang.org, and that's it. Thank you very much. Do we have time for questions?
Yes, we have a lot of time for questions.
Okay. We have a lot of time for questions.
General problem with, especially column list, is that it's too much powerful, so it's hard to develop in companies. Clojure tries to address this with some kind of idiomatic definition of code. What is idiomatic, what is not. The same Python. Does Elixir has some kind of this stuff, or maybe there's other property
that's a good question. Since the language is still very fresh, right? It's hard to already have the idiomatic way to do things, right? I think this is something that will come with time, right? Even sometimes when I'm using the language that I wrote, sometimes I do something and I say, wow, I didn't know that this worked, right? Sometimes you are impressed by how the things are wrapped. So I hope so. I hope that eventually when people start to use it, they can see a common point and they can say like, oh, this is the idiomatic way of doing X or Y, and the community can build on top of that.
Are you planning for some sort of library like Rails itself?
So this is kind of a hard question because I'm part of Rails core, right? And the thing is, so I have a kind of a bit biased point, and I don't think that Erlang or Elixir can somehow provide the same things of Rails. Not because it's basically because of the things that the language prioritizes, right? So you have some kind of impedance there, and the fact that in Ruby you can basically distort things the way you want, you can monkey patch stuff. This suits very well with the idea that Rails helps you to do rapid prototyping, right? And this is something that I find hard to beat, even if you have an explicit compilation step. So what I want to do, basically, is that Rails is great for this kind of stuff, and I think it's hard to beat it for those kind of applications, but we are seeing a lot of new applications coming out, which basically, for example, why Node.js is getting a lot of traction, because people are moving stuff to the client, and people are there, like, let's say, dumping down the server, and in those cases, I think that Elixir and Erlang could really shine, right? Node does not even use 2 cores, right? We have really better tools to expose to the community. So that's the idea. I want to build a framework. Do you know Sinatra from Ruby? So the idea is that it's going to be very Sinatra-like and oriented about resources, because you're going to build APIs with that. you're going to maybe build sockets and long-run connections. So that's the idea.
So you're working for a telecommunication company?
No, it's basically web development company.
Web development.
Yeah.
I found that there's something with fun, and I didn't hear any protocols, phone protocols on the web sockets.
No, it's basically we build applications both from the server to mobile clients and so on. So that's what we want to do. We want to be ahead and have very good solutions.
Does Elixir language has everything web-oriented inside, or it's absolutely general purpose language?
General purpose. So everything that's web related is going to be in another library, which is Valim. I'm using this web library as the requirement to build a language. So every time I need the language to do something, the requirement comes from the web library. But the idea is that it's going to be general purpose.
How do you feel about the duplication of efforts? Because you're doing things which have been done in Cowboy, Insultin, nitrogen stuff. Do you want to reuse them? Or?
Yeah, so the question is about the duplication of efforts, because we have web frameworks and web servers and everything. So I'm reusing the web servers. I'm not reusing the web frameworks because I cannot reuse them. So I'm trying. The whole idea is that I want to use the Erlang infrastructure the maximum I can, and that's something I will encourage people to do. Right? If you already have something in Erlang that does it well, there's no reason to duplicate the fork. Just join and do everything. I think that a person that knows Elixir, let's suppose today most of the people they actually know Erlang and then they learn about Elixir and start using Elixir. But if this flow eventually change for some people, they start Elixir, I think it will be like very easy for them to go down to Erlang, right? The difference is just, there is no semantic difference, the difference is just in syntax. And then Erlang syntax, it's easy to learn, so I think it will be able to, I would like in the future to be able to get a lot of attention from people, and the fact is not to grow apart from the Erlang community, but to grow stronger.